So this will be the end of section 8.6, and just because we're at the end, maybe I should do your problem as opposed to do my problem and see where it takes us, which means this information is not going to be correct. Let me start by finding the point of intersection between the two lines. It's an important point that I want to graph. So the point of intersection in problem 33 between the line version, not the inequality version, of x plus 2y equals to 8 and 2x plus y equals to 7. I'm going to get by the elimination method. I'm going to start off, I'm going to multiply the top equation by -2 to force the x's to drop out. This will make the top equation -2 times x, which is -2x, and then -2 times y is -4y. -2 times 8 is -16. I'm going to leave the bottom equation 2x plus 1y equals to 7. And when I combine these, the x's drop out. I get -3y equals -9. Divide by -3, divide by -3. I get y equal to 3. I need to solve for x. I'm going to use x plus 2y equals to 8 and plug in my y equal to 3. This will give me x plus 2 times 3 equals to 8. That's x plus 6 equals to 8. -6 minus 6 gives me x equal to 2. So the two graphs that are slanted are going to intersect at the point 2, 3. I'm going to plot that point and make this sheet disappear. Not going to need it for the rest of this problem, but I needed that point. It's an important point. So I'm going to plot the point 2, 3, and it's probably going to be one of my corner points. Usually that point of intersection is. Let me lazy graph these. First of all, I'm going to work on x plus 2y is less than 8. I can tell the intercepts. If I cover up the y, the x-intercept is 8. If I cover up the x, you get 2y equals 8, you get y equal to 4. If you can get the intercepts in your head, great. If not, do the algebra. So x plus 2y equals to 8 to find the intercepts. For my x-intercept, it's x plus 2 times 0 equals to 8. This gives me x equal to 8, x-intercept of 8, 0. For the y-intercept, I do 0 plus 2y equals to 8. This gives me 2y equals to 8. You divide by 2, you get y equal to 4. That's the point 0, 4. So I need to plot the point 8, 0 and the point 0, 4. And I get a dashed line because I don't have the or equal to. And I'm going to make my graph go through that intersection point because it has to. So dashed line because I don't have the or equal to. Make sure I go through the intercepts. And lazy, there's nothing but pluses. Less than is down, greater than is up. This guy right here is going to shade down. Next one, 2, that's a horrible one. I'm glad I'm doing this. 2x plus y is less than or equal to 7. X-intercept, I'm going to start off with 2x plus y equals 7 and let x be 0 for my x-intercept. Let y be 0, should I say, and get 2x plus 0 equals to 7. That gives me 2x equals to 7, x equal to 7 halves. It would be fine to say the x-intercept is 7 halves comma 0. I don't know how to plot that. So I'm going to call it 3.5 comma 0, the decimal equivalent. So the x-intercept's at 3.5. And then for the y-intercept, I'm going to go 2 times 0 plus y equal to 7. That's going to give me y equal to 7 and give me 0, 7 for the y-intercept. Now I'm going to connect with a solid line on this one because of the or equal to. Make sure I go through that point where they intersect. Best I can. And since there's nothing but pluses, less than's going to shade down. I'm going to be under this line as well. Both lines are going to shade down. This graph right here is actually going to go through 0 on the x-axis. It's going to be the y-axis, and I'm going to shade right. So for the x greater than or equal to 0, I get a solid line through 0 on the x-axis, which is the y-axis, and I shade right. So find 0 on the x-axis, make my solid line that goes through it, and I'm going to shade to the right, trying to emphasize where all the shadings are going to overlap. The y is greater than or equal to 0, you get a solid horizontal line. I get a solid line through 0 on the y-axis, and I shade up. So I find 0 on the y-axis, draw my solid horizontal line, shade up. So for my shadings, I need to be in this little trapezoidal region. I need to be to the right of the y-axis, above the x-axis, and beneath both lines. So my shading is going to be that area right there. That's the region where all 4 shadings overlap. And then corner points are any point that's an x-intercept, a y-intercept, or a point where lines intersect. The lines intersect at the point 2, 3. I have the point 3.5, 0 as that x-intercept. That 0, 0 is an x and a y-intercept, and this 0, 4 is an x-intercept. These other x and y-intercepts out here, because they're not around the final shaded boundary, aren't considered corner points. So my corner points are going to be 2, 3, 0, 4, 0, 0, and I like the decimal better for graphing purpose, 3.5, 0, but you could write 7.5, 0. One more, let's do 35 together, as opposed to 36, which means my corner points aren't correct. And let me find the point of intersection first. It's an important point. So my point of intersection between x plus y with an equal sign 4 and 3x plus y with an equal sign 6, I'm going to use the elimination method. I'm going to multiply the top equation by -1. I'm going to get -1x minus 1y equals -4. And then the bottom equation doesn't need to change. I can add these together. -1x plus 3x is positive 2x. I designed the y's to cancel. -4 plus 6 is positive 2. Divide by 2, divide by 2. The x coordinate of where they intersect is x equal to 1. I need to find the y by using x plus y equal to 4. Plug in 1 for x. I get 1 plus y equal to 4 minus 1 minus 1. And I get y equal to 3. So the 2 slanted lines are going to cross at the point 1, 3. This sheet can die now. I won't use it again for any of the shading, but I need it for my graphing. So I start off and I plot the point 1, 3. That's going to be a corner point always. This is tricky because of the things are going to shade up. If there's nothing but pluses, x and y on the left side, constant on the right side, less than shade down, greater than shade up and away from the origin. So for the x plus y is greater than 4, I'm going to find my intercepts. Think of it as an equal. First do the x-intercept and do x plus 0 equals to 4. That gives me x equal to 4. That's going to be the point 40. Hopefully you can do these in your head. For the y-intercept, I plug in 0 for that x and do 0 plus y equal to 4. I get y equal to 4. That's going to be the point 0, 4. So 4, 0, 0, 4, dash line because I don't have the or equal to. Make sure I go through the point of intersection because that's the reason I found it. The lines all have to go through that. The slanted ones do. Dash line. And greater thans, if there's no minuses, are going to shade up. So that line's going to shade that way. Move on to the 3x plus y is greater than 6. Change it temporarily to 3x plus y equal to 6. Do the x-intercept by going 3x plus 0 equals to 6. That gives me 3x equal to 6. Divide by 3, and I get x equal to 2. That's going to give me 2, 0 for the x-intercept. For this y-intercept, I'm going to go 3 times 0 plus y equal to 6. That's going to give me y equal to 6. That's going to be the point 0, 6. So I plot the point 0, 6, the point 2, 0, connect them with another dashed line that also goes through that point of intersection. And this is also going to shade up because it's nothing but positives and it's a greater than. The line x is greater than or equal to 0. I draw a vertical line through 0 on the x-axis and I shade right. So the x is greater than or equal to 0. Draw a vertical line through 0 on the x-axis and tell myself I shade to the right. The line y greater than or equal to 0. I draw a horizontal line through 0 on the y-axis, and I shade up. So I have to analyze where all my shadings go. I go to the right of the y-axis, above the x-axis, and above each of the slanted lines. So I need to stay in the first quadrant. I need to be to the right of the y-axis, above that dashed line, above that dashed line, and above the x-axis. This is kind of the boundary of where I'm going to shade. This is the region that's to the right of the y-axis, above the x-axis, to the above the first dashed line and above the second dashed line simultaneously. This is going to be considered the shaded region for problem 35, the very last new problem that we have to do this semester. And now I'm going to list the corner points. The corner points, I go along the edge of the boundary, or the edge of my shading, and any point that's an intercept or where two lines cross is considered a corner point. So this point down there, the point 4, 0 is going to be considered a corner point. It's at an x-intercept along the boundary. This point right there, the point 0, 6, is going to be considered a corner point, as is the point 1, 3. I'm not going to consider the point 2, 0 or 0, 4 because there's no shading next to them. So my corner points are going to be the point 0, 6, the y-intercept on the edge of this shading, the point 1, 3, where two lines cross on the edge of the shading, and the point 4, 0, the x-intercept on the edge of the shading. Okay, that's it, other than we need to get through the practice test. Hopefully we're feeling good about this chapter. There's a lot going on, and it's our last chapter. Definitely want to make this a good test, not have to take the final. The final is only to replace your lowest test. If you don't have a bad test that's weighing your grade down, then after this test you can be done with our class.